We're almost there. We're almost ready to explain why there are different levels in the atom for the electron. And this is going to require us to do these things called commutation relations. And this will help understand how the spins interact when you have more than one electron. It's not as simple as, okay, one's pointing up, one's pointing down, and they fit together. It's not like that. It's much more abstract. But once you see how the numbers in algebra work out, it'll all make sense to you. Okay, here's a strange thing. If we measure x and then measure y, that's going to give a different result than if we measured with y first and then measured with x. Now that may not seem strange, but it's pretty strange because the previous measurement affects what this one is. So let's look at the spin x operator, which is this thing. You may not remember that, but you can go back to video 10 if you wish to dive into that. And here's the spin y operator. Here's the matrix stuff. Remember the matrix stuff. It's going to get a little bit more advanced because we'll be taking a matrix times a matrix rather than a matrix times a column. H bar over 2 has to go on each one of these, and that's part of the multiplication. So this ends up on this other side being h squared over 4. And then we have the two matrices lined up. So this element is row 1, column 1. So we take row 1 times column 1. That'd be 0, 0 times 1i. We get an I. Then we take a, okay, that was one element. This element is row 2, column 1. Here's row 2, column 1. Oh, column 1. See, I can't even keep it straight. Row 2, column 1. Those all end up being zeros. This element is row 1, column 2. Here's row 1 times column 2. That all zeros out. And then finally, row 2, column 2 gives us minus I. Now this should look familiar because this is very close to the format for the z spin operator. So if we subtract, or if we factor out the I, we get I h squared over 4 z operator, but the z operator has an h bar over 2 in front of it, so it really becomes this form. Do the same thing for sy sx. This element is determined by row 1, column 1. Row 1, column 1 gives us a minus I. Row 2, column 1 gives us a 0. This would be row 1, column 2. That gives us a 0. And finally, this one down here is row 2, column 2. Row 2, column 2 gives me an I down here. Now, I'm going to factor out a minus I from here, and then it'll be the z operator. So, going this direction, sy first, we get a negative IH bar. That should be a bar over there. I left that out. SZ, and this one becomes a positive IH bar over 2. If we lump all these things together and try to subtract them, then we get an IH bar minus a minus IH bar, and that gives us IH SZ. So it comes out nice and cute. If we want to compute the others, this is what happens. And you're welcome to try those yourself. It'd be good practice. And this is called, this little symbol where we have a bracket and two items with commas, that is a commutation relation. If I were you, I'd be getting anxious about something that looks like chemistry, because we're looking at one little electron spin, and that's not a whole lot to go on. So let me give you a review of where we've come from, and hopefully you'll keep your interest going here for the following videos. This is where we came from. We just introduced it, and guess what? We talked about spin. We talked about spin in that very intro. Then there's spin. Then there's spin. Then there's spin. Then there's spin. Then there's state vector. State vectors. We started focusing on that and the different measurement bases. Then we had the Hilbert space thing, which I probably lost lots of viewers that were. I don't have many anyway. I mean, like 2 or 3 viewers, so what am I talking about? Then we did that half angle proof, and we did the spin operators, and now we just did the commutation relations. And where do we go next? Well, let's see if I can get this to come up right. Okay, here's where we're going. 2 spins, 1 state. Now that's, guess what? 2 electrons. That'll get us up to helium. Okay, and here's some other things. And then finally, paired versus unpaired electrons. And then finally, we start talking about atomic structure. Can you wait that long?